This is a lecture video for the Non-Renewable Resources content page. Make sure you read the content page first. There's a lot of good information in there, but I'm going to go into more detail about the fossil fuels. And so, before we look at the fossil fuels, we have to understand what energy is. Now, energy is just the ability to do work, the ability to exert a force, some sort of force that can move something. I mean, essentially, what energy is just a force that can move stuff, right? We generally use things that we can burn to generate thermal energy to move things, like the engine. The engine literally has components that if you move them, they spin the wheels of a car. And so people figured out that if you put some kind of explosive fuel inside these cylinders, when it explodes, if you think about an explosion, it just blasts things away. The explosion can move some metal, which can eventually move the wheels of the car. So an engine, the reason that it sounds like it does is because it's just a series of explosions, small, controlled explosions. Now, after we made the engine, one of the best things that humans have created or harnessed the power of is electricity. And we use these turbines for electricity. Now, I'll remind you, if you didn't get this before, the turbine is just something that can spin, and when it spins, it's connected to magnets and copper coil, and when those magnets spin inside or around the copper coil, it makes electricity, right? So what we do is we usually use water. Most civilizations use water. They boil the water, and that steam gets forced onto that turbine, which spins it, which generates electricity. Now this is great, but you have to have something to burn here. And so we usually use things that burn for a long time and they burn very hot. And those more than likely are going to be non-renewable resources. And so a non-renewable resource, as you know, is a natural resource that cannot be readily replaced by natural means. And it's about the time. It cannot be replaced at a fast enough pace to keep up with how much we use. And these are the common ones. Okay. Oil, coal, natural gas, and nuclear energy. Nuclear energy is here because we use uranium, which on the Earth, there's only a certain amount of uranium, and when we use it all up, it will not replenish itself. Let's talk about coal. How do we get it? Well, coal, you saw some in class. I showed you that sea coal, made from woody plants under compression, heat, and pressure, underground for millions of years. It is extracted from the earth in two ways. They either surface mine it or they underground mine it. Underground mining usually has the tunnels. People go deep into the earth and they literally just hammer it or pickaxe it out of the ground and bring it up. And here's some surface mining. This is how they do that. Now, as you can tell, if there was any kind of forest here, that's obviously going to be destroyed. The problem with the underground mining is sometimes, well, often, when they abandon the mine, when there's not enough coal to get out to make a profit, water will leach into these mines when they're abandoned, and over time, that mining water, it's called acid mine drainage, can actually end up getting into the water source for a town or for a forest, and it has a lot of pollutants in it, and so that can also affect the environment. That's where the water pollution comes from. Now, when you do things like this, moving all of this earth or digging these holes, obviously you're going to create a lot of pollution from burning other fossil fuels. And they use different chemicals to explode the earth to break through rock. And they use certain chemicals to extract coal from the ground, and all of those things can release harmful pollutants. NOx, that could be NO, NO2, NO3, SOx, the X represents a number, SO2, SO4, and CO2. And obviously, if you're a coal miner, you have respiratory issues, neurological, that's brain problems, and CVD, cardiovascular issues. Now, natural gas is very similar, except gas is not oil. It's a gas form. It's methane. So the way that we get it is you can do standard drilling. You can drill into the ground, or what's very common now is what's called fracking. Now, fracking is still when you drill into the ground and they find somewhere where natural gas is. And what they do is they use think about it as mini explosions or very loud sounds that fracture. That's why it's called fracking. The rock releasing the gas. Now you might say, how do they actually get the gas? Doesn't it just go up into the sky? Well, a lot of it can be released to the sky, and we know how bad methane is as a greenhouse gas. But what they do after they frack a little bit, they crack the rock, they force fracking fluid in there, which is a mix of water and a bunch of other chemicals, and they put it at really high pressure so it fractures the rock even more, and then the methane gets dissolved in the fluid, and they take the fluid out. Now, this is dangerous because there are studies that actually show for sure that all of that fracking, if you do it enough, it can increase the likelihood of earthquakes. And also, that fracking fluid that has all the chemicals in it, a lot of times that fluid leaks and goes into the waterway. But also, when they drill these wells and they put that fracking fluid down there and they make it at high pressure, a lot of times it'll crack the rock so much that it actually will go into groundwater, which a town might be pulling up and drinking. And that fracking fluid is very, very toxic. It leads to neurological issues, child leukemia, birth defects, things like that. Crude oil, again, we have to get it out of the ground. And the most common way is just drilling wells. They have these wells on the ground. They also have them in the ocean. One of the worst oil spills ever was in the ocean like this. A lot of times these platforms aren't even fixed, they're floating. And if any part of this leaks, it can leak for a very, very long time, especially if the oil well is really deep under the ocean. So they drill in the ground and they pump it out. Obviously, oil spills are bad, biodiversity loss from all the drilling, groundwater contamination, ocean contamination, and the usual NO, SO, and CO air pollutants. And these are the human health effects if you have oil on you working in the oil industry, crude oil getting in your skin, working with it for a long period of time. Now, the last one that we haven't really talked much about is nuclear. So what we do is we take uranium, which is an element. It's a radioactive element. It's unstable. So it breaks down by itself. We take that out of the earth by mining, just like we do for coal. Except this is used a little bit different. We don't burn this. What they do is the same process is used at a nuclear power plant, except instead of using fire and burning a fossil fuel, what we actually do is the uranium, since it goes through fission, it splits apart, and when it does that, it releases tons of energy in the form of heat. What they do is they'll put a ton of uranium inside this water in a very more complicated way that I'm saying, and when it starts to split or go through fission, the energy of the fission actually boils the water itself. And this is actually so powerful. If the fission happens and is so hot that they have to put a lot of things in play that can slow down the fission process and make sure it doesn't overheat, because then that can lead to a nuclear meltdown, they call it. I mean, when everybody hears about nuclear, they always think of how dangerous it is. And it is very dangerous because those nuclear wastes, as you know from Half-Life that we did in the beginning of the year, those things stay radioactive for up to 1 million years, right? Hundreds, thousands to millions of years. And radiation can damage our DNA, any animal, any creature, any living thing's DNA. So although these meltdowns haven't happened that often, if they do happen, if it's a bad, large scale, they can have detrimental effects for a very long time. Here is what it looks like when they use nuclear energy to boil the water, to move the turbine. These are the non-renewable resources that we use for energy. If you do the extra credit, I go into a lot more detail with this, but that was just a general overview.